What's up everybody, and welcome to the last video of my What's Machine Learning series. In the previous videos we talked about how machines learn and what they learn, and we've also seen many different examples of that. And in this video I want to address the question why all of that might be important. Or in other words, given how and what machines learn, what might be some possible implications of that. And therefore I'm going to introduce to you three basic premises on which I will base my argument. So the first one is that every human action is aimed at a desirable goal. So for example, if you drink something, you want to satisfy your thirst. If you're studying for an exam, you want to get a good grade or a good degree. Even if you don't want to do anything at all and just watch Netflix, your goal might be to be entertained or just relax. So no matter what you do, it is always aimed at some kind of reward. That's the first premise. The second one is that every action is preceded by a decision. So before you do something, you have to actually decide what you're going to do. And the better that decision is, the more likely you are to attain your goal. That's the second premise. And the third one is that math is the most precise way to make a decision. If you can somehow calculate a relevant number, then instead of just, for example, relying on your experiences, then you can compare different courses of action and choose the one that results, for instance, in the highest score or the highest probability. So those are the three basic premises, and for the sake of the argument, we're going to consider them as being true, which I think is relatively reasonable, not too much of a stretch. So now, if you look at the history of humankind, we can see that over the course of thousands of years, humans developed ever more sophisticated mathematical methods. And in the context of our premises, this development makes perfect sense because humans want to improve their lives and therefore they pursue different goals. Therefore, they have to make the right decisions in terms of what to do, and the best way to do that is math. So accordingly, they developed ever more sophisticated ways for doing that. And along the way, they also developed ever more sophisticated calculating machines. And with the help of those machines, they could then automate those calculations, which made them much faster and also less error prone. And this development culminated in the creation of the digital computer. However, there was one critical distinction between the computer and all the calculating machines that preceded it. Namely, the computer could be programmed to execute any arbitrary sequence of instructions. And this means that it couldn't just be used for one specific task, but instead it could be used for a huge variety of tasks. And again, in the context of our premises, one could now assume that having such a general purpose calculating machine might have a huge impact on humanity. And indeed, the computer is probably one of the most important inventions. Just imagine you would turn off all the computers that exist in the world today from one moment to the other. The result would be complete chaos because nothing would work anymore. That's how pervasive computers are. But one question arises with respect to computers, namely, if they are a general purpose machine that could be used to do basically any task, why then aren't they able to do some specific tasks? For example, up until very recently, self-driving cars, speech recognition or image recognition were tasks that couldn't be done by computers, at least not at a human-like performance level. Why is that? Well, it's because even though computers can be programmed to do any task, they still have to be programmed by humans. And this is the limiting factor, because even though we humans are extremely good at taking in large amounts of information through our senses and then examining this information for patterns, we are extremely bad at describing or figuring out how we exactly do that. And this came to be known as Polanyis Paradox. He famously said, "We know more than we can tell." And what this means is that it's extremely difficult, if not even impossible, to clearly express our implicit knowledge and transform it into explicit words that a computer could execute. So for example, let's take the field of image recognition. And let's say you want to create a program that can detect which animal in an image is a cat and which animal is a dog. For humans, this is an extremely simple task, and we immediately know that this is the dog and this is the cat, even though they look relatively similar to each other. But how do you now translate that knowledge into some specific words that a computer could execute? It's simply not possible. At least it won't result in a human-like performance level. And this is exactly where machine learning comes into play. Because as we've seen in the previous videos, there's no need to program any explicit words so that the computer can achieve this task of detecting cats or dogs. All that is needed is some data, and then the computer will learn on its own how to achieve it. And in doing so, the computer, so to say, indirectly learns all those words that are necessary for detecting cats or dogs. And this is the big difference between machine learning and what is called hard coding a task. And now, the next obvious question is, if machine learning is a potential approach for tasks where Polanyis Paradox is present, then how does its performance stack up against humans and their implicit knowledge? Unfortunately, a team led by psychologist William Grove did a meta-analysis to answer exactly that question. And they examined 136 studies where a human expert went up against a statistical approach. And the tasks covered in those studies were as diverse as, for example, predicting college academic performance, diagnosing heart disease, or predicting magazine advertising sales. And the results of this meta-analysis were pretty clear. In 46% of the studies, the human experts performed significantly worse than the algorithms. And in another 48%, the human experts performed as well as the algorithms. But here, one has to keep in mind that once the algorithm is in place, it can run all the time and also make those decisions much faster than humans, which makes it also much cheaper. So if you now combine those two groups, then in 94% of the cases, algorithms were superior to humans. And that leaves only 6% where the human experts performed better than the algorithm. But there's also a caveat here, because the authors of this meta-analysis don't think that the algorithms performed worse because they couldn't do those tasks, but simply because the experts had more data available. And on top of that, if you look at the studies of this analysis, then you will see that the newest ones are from 1989. And as you may know, the most impressive advances in machine learning, especially deep learning, were made in the last couple of years. So the algorithms of today would perform even better. And now, going back to our question of how machine learning stacks up against humans, the answer is pretty clear. Namely, if enough data is available, then data-driven decisions basically always outperform human decisions. And as you probably know, having enough data becomes less and less of a problem because the data created worldwide keeps growing exponentially. And this leaves only one conclusion, which is also the answer to my initial question. Namely, more and more decisions will be made by machines, especially if those are decisions from repetitive or non-creative tasks. And in the previous video, we've seen some examples of such decisions. And now, referring back to our premises, this development will lead to more and more better and precise decisions because they are based on data and math. And this then will lead to taking the right actions to achieve our desired goals. So the impact that machine learning will have on the world can probably not be overstated. If we just consider, for example, the impact that computers had on the world as a reference point, then the impact that machine learning will have will be even much bigger because it amplifies the capabilities of computers. On the one hand, all those tasks that could be done so far by hard coding them can be now even improved upon because they can be based more on data. And this fact alone will probably have a huge impact. But additionally, all those tasks that couldn't be done so far by hard coding them are now feasible. So in conclusion, machine learning will definitely have a huge impact on the world. And this means on an individual level, there's a huge opportunity if you are proficient at machine learning, because companies will have a high demand for such people. And therefore you obviously have to have a firm understanding of the basics of machine learning. And since deep learning is one of the most powerful algorithms in recent years, in one of my next video series, I'm going to cover the basics of deep learning. So, thanks for watching, and hopefully I will see you in the next video.